So this is our website, and till now, what we have discussed is about Android. What is the architecture of the Android operating system? And after that, we also discussed about ADB, that is Android Debug Bridge. Then we learned what are the various commands that we have with ADB. After that, we learned how can we set up ADB with our emulator with our Android device, practice with it. Then we learned about APK, architecture of APK. It is an archive. We can extract it. We can pull any of the APK from the apps that are installed in our device in our emulator. Then we decompiled it with the help of APK tool, with the help of dex2jar, with the help of 𝗧𝗿𝗶𝗶. This is what we have discussed till now. When we were discussing about the architecture of APK, we came across one of the files, that is Android manifest.xml. That time I discussed that at the moment I'm skipping on Android manifest.xml, but I will get back to it because this is one of the most important things that we will have to review, that we will have to analyze for the sake of security. So in today's discussion, we will be discussing about the Android manifest file, what it is, why is it mandatory for every app to manage the Android manifest file, what are the contents. As a pen tester, as a security researcher, as a bug hunter, how do you analyze it for security issues? Like from the perspective of the security, how do you analyze manifest? How do you analyze Android manifest elements? And then what are some of the best practices that you should be following or you should be recommending the developers of your organization, of your client's organization, that these are the things that you should definitely do in your Android manifest. So this is what we will be discussing today. We will be majorly discussing about Android manifest and all of the various components that we have in an application, like activities, intents, intent filters, users permission, content provider, services, all of the app components that we have, we will be discussing them. All of those things that you can expect in the Android manifest file, we will be discussing that as well. Android manifest, this file is mandatory in each of the Android application. When using Android Studio or any of the other IDE, you will be developing an Android app. You will see that the Android manifest file, it is automatically being managed. You will see that the Android manifest file, it will automatically be managed by the Android Studio. Why do we have the Android manifest file? So that all of the permissions that the apps require, all of the activities that are present in that app, all of the content providers that we have in the app, they can be mentioned. If in case anything is not described in the Android manifest file, the app will not be able to execute it. The app will not be able to request for it. For example, in your Android app, you require the camera permission. If in the Android manifest file, you have not mentioned that this app will be requiring the camera permission, that app will not be able to request for the camera permission. So Android manifest.xml, this is basically a binary XML file. When that particular app will get compiled, we have already discussed the Android source code compilation process. When that app will get compiled, that Android manifest file, that will also be compiled. It will be coming in the XML format. After compiling, it will be a binary XML format. We have seen how can we pull any of the APK with the help of ADB. We saw it for Twitter, like here, this is the twitter.apk. Then with the help of APK tool, we decompiled it. This is the response that we have. The same thing that we did previously, this is the output for that. And here we have got Android manifest.xml. So if you want to open this, because it is a decompiled version now, it is in the high level language, it is not a binary XML file anymore. So you can simply open it with any of the text editor. I have Sublime installed in my this VM. For that reason, I'm writing Sublime. If in case you are using any of the other Linux flavor, like you are using Kali Linux or you are using Ubuntu, you can use any of the other text editor as well. So any of the text editor would do. We just need to open this file. So you do text editor name, like if it's Ubuntu, you write gedit. If it's Kali Linux, you write mousepad or touchpad. Or you can also install your favorite text editor and you can open it. So here, once I open this Android manifest.xml file, this is what I will get to see here. So the first thing that we see here is this keyword, that is permission. When any of the app will be mentioning any of the permission, like here you can see this is a custom permission com.twitter.android.permission.maps receive. So here this is a custom permission that this app will be having, like com.twitter.android.permission.c2d message, com, Twitter, Android, permission, restricted. These are the custom permission. Another keyword that you have here is uses permission. These are all of the various permissions that will be required by this app to run. So when you will be opening Twitter app, these are all of the permissions that will be required. Like here you can see android.permission.access network state, android.permission.vibrate. And as the name suggests here, with the help of this permission, the Android app, this particular Twitter Android app, it will be able to vibrate the phone. I mentioned that in the Android architecture, you will be having various layers. So for you to be able to interact with the hardware, you have got hardware abstraction layer. Above that, you will be having the native libraries. So with the help of these permissions, you can give your consent as an user that this is the permission that I want to give. For example, when Twitter wants to read the contacts on your phone, it will be requiring this particular permission. If you click on allow, this app will be able to read the contacts. If you click on deny, the permissions will not be given. So here, this is the user's permission here. So these are all of the permissions that will be required by this app to run. Along with that, what are the various hardware features that this app requires? You will be able to see that in the users feature. If any of those things are required, they will be mentioned here. If they are not mentioned here, it is understood that they will not be required. The app will not be able to use it. Like if the Twitter app wants to access the location with the help of GPS, it wants to access the location. Here you can see uses feature android.hardware.location, android.hardware.location.gps, android.hardware.telephony. So when any of the phone call will be received, any of the phone call is to be made, for that we have got this telephony. After that, the next term that we have here is service. Service is an important Android app component. Service simply means a background process. In any of the application, if you say that there is something that is running in the background that is without the user interaction, it means it is running as a service. You must have seen it sometimes that you are using WhatsApp. You lock your phone and you put it aside. Still, whenever you get a new message, you get a notification. What is happening in the backend is the particular WhatsApp app, it is running a service, and after a specific amount of time, after every second, after every couple of seconds, it is checking with the server whether we have received any of the new message or not. So even if in case you are not interacting with the target, still that particular in the background, that will be running, and that is what we call as service. So a service will simply be running in the background without even any of the user's interaction. In any of the Android app, user interaction plays an important role, because on the basis of the user interaction simply means that the user is actively using the app. User is clicking somewhere, user is swiping somewhere. So that user interaction in the Android apps, user interaction plays an important role. You must have seen that in the settings of our Android devices, we have screen timeout, that after 15 seconds you can turn off the screen, after 10 minutes you can turn off the screen. So if in case we do not interact with the device, if we do not interact with any of the app, any of the activity, in that case, after a significant amount of time, like 15 seconds, 30 seconds, 1 minute, the screen will be first dimming for a few seconds and then it will be off. So in service, I'll be repeating myself. Service will be running in the background without any of the user interaction. Along with service, another thing that you need to know is the activity. Consider it this way, that you have got an application for Zomato. So when you open Zomato, you first see a screen that shows the Zomato logo. So that Zomato logo that you see here, the first screen that comes up, that only has the Zomato logo, and after a few seconds it will go away. We call it a splash screen. A splash screen is when you open any of the app, and for a short period of time, the screen that contains the no logo, the name, or maybe loading, that is the splash screen. So that is the first screen, that is the first activity. Then when you go to the login page, you click on login, that is the login activity. Then once you are logged in, you get to see all of the pages where all of the restaurant are, put up. That is another activity. In any of the Android app, each screen that you have, like in our example, we first had the splash screen, then we had the login screen, then we had the restaurant screen, then we had the my orders screen. Each of the screen will be a different activity, like that. So I can also fire up my Android device here so I can show it to you. Activity is every screen that you have on that Android app, that is an activity. Each unique screen is an activity here. So I'll be writing this down, is an activity. Now everything related to that Android app will be happening in the activities. Activities is what you see on the screen. Each of the activity it will be having a life cycle. We have already discussed about the Android app life cycle. So here I can repeat myself. So in any of the app life cycle, there are 4 stages. In any of the app life cycle, activity life cycle, there are 4 stages. We have already discussed it. I will just give you a brief recap. The first one that we have is the foreground. When the application is running, when the activity is on the top and the user is interacting it. Technically, we call it that when the activity is on the top of a stack. Now, a new term has been introduced to us, that is stack. In real life, the term stack means putting everything one above the other. For example, you are at your house and there is a party. So you have called some of your friends, some of your relatives that please come over, and you require some extra chairs. So what you do, you go to your neighbors and you borrow some chairs. Let's say you get yourself some 20 chairs, and what you do, all of those chairs you put one above the each other, like this. I can show you the image so that the things become a bit easy for you. A stack of chairs like this here. So this is known as a stack. 1 2 3 4 5 6 7 8 9 10 11 12 13. All of those chairs will be put right above the each other. This is the stack. In activities, when you will be running any of the new activity, what happens is that activity will be coming on the top, and all of the other activities that you have, they will keep on running below it or behind it, because it is happening that any of the new activity that comes up, it will be placed on the top of the current stack, and it will only the top of the stack will be shown to you. All of the other activities that will be running in the behind, they will not be shown. So till you exit the current screen, until you exit the current activity, you will not be able to see the other ones. So this happens this way, that you will be having a stack of the screens. Like, let's say you are having Zomato. So you simply go to Zomato, you click on their application, then you get the login screen, you complete the login, and then you see the orders page. You go to the orders page, you then go to, let's say, payment. So what happens is, first you will be having login, then you introduced orders, so orders came on top of it. Then you go to payment, that comes on top of it. You go to track rider, that goes on top of it. So when you kill any of the activity, you come back from any of the activity, then the one that you have right below it, that is shown, then the one right below it, that is shown, then below it. Like this it works. So any of the new activity and of the new screen that will be coming, it will be coming on top of them. Like here, this is my Android device, and here let's say I turn on the Twitter app. So here I turn this on. Here this is the main screen. Please keep this thing in mind, that for the first time when any of the app that will be running, its execution always starts with the main activity. In any of the source code, when you will be running that app, the Android will first of all be looking for main activity. This is where the execution of the code starts. So this is the main activity. Then when I click on login, you can see a new window, a new activity has been shown to me. So here I can enter the details like this. So this is the login activity. Then here we have this sign up. I click on this sign up, and this is the sign up activity. Here, this is the sign up activity. So first we had the main activity, above it we have the login activity, above it we have the sign up activity. All of the other ones are also running in the background, in the, right below this, right this below this sign up. So if in case I go back, you can see this is login. If I go back, this is the main activity. If I go back here, this is the menu, this is the app menu, like this. So each and every screen that we have seen here, like this main activity, this sign up, this login, all of these are activity. Each screen is an activity. When you are actively using the top, when you are actively using the activity, when you are actively interacting with the app, you call it the foreground app or the foreground activity. When you are interacting with it, so that is the first stage, that is foreground. The next stage that we have is visible. So in visible stage, what happens is that this particular activity, it will be visible to the user, but the user is not interacting with it, the user is not using it, the user has lost the focus. That is when we call that this particular activity, this particular app is now in the visible state, that it is being shown on the screen, but the user is not doing any of the action, is not doing any of the interaction. So when activity is visible but user has lost the focus, you can consider it this way, that in WhatsApp you are, chatting with someone, and while you are chatting you have sent the message, and some of your friends are sitting beside you, so you have sent the message, you are waiting for the reply. The app screen is open, that chat is open, but you are now waiting for the reply, you are not doing anything on the phone. The phone is just open, it is unlocked, the chat is open, you see that the other person is typing, and by the time they type, you are having a conversation with your other friends. So in this case, as you see, the activity is visible. It is being shown on the screen, but the user has lost the focus. The user is not interacting with the screen, is not interacting with the activity, is not interacting with the app. That is when we go to the second life cycle, the second stage of the life cycle, that is visible. When the activity is visible on the screen, but the user is not interacting with it. The third one that we have is stopped or hidden. We have already discussed it. I'm just giving you a revision. The third stage that we have is stopped or hidden. It means that the activity that we have, the stage of that activity. For example, here I have mentioned my email ID. Here I have mentioned my password like this, and this particular stage that I have for this activity, this particular activity state will be retained. This will be as it is, but the activity is not shown to the user. For example, you have got the Zomato app, you have added something to the cart, and then you are back with any of the other activity. Now when you go back to that particular specific cart, when you go back to that activity, all of the things that you have done, like on the registration form or in the address form, you have mentioned the details. So the state that we had for that activity, it is retained, but it may not be shown to the user. So that is when the app or the activity is in the third stage, that is stopped or hidden. Now in this stage, the app can be killed or the activity can be killed by the Android system. If in case some more memory is required or some more resources are required for the other apps or even the Android OS to run, Android system to run, all of those activities that are stopped or that are in the stopped or in the hidden stage, they may be killed. It's not necessary that they will always be killed, but they may be killed. They may be terminated. So that is the third stage. And the last one that we have here is the destroyed, which means that the app or the activity that was running, it has now been terminated by the Android OS because it required more memory. So if in case there is any of the app or the activity that is running, that is consuming memory, that might be running in the background, but there is no interaction happening with the user, for the sake of memory, for the sake of survival, Android operating system might terminate it. Consider it this way, that you have got an email client. Let's say you have got Gmail. Gmail will continuously be looking for new emails every now and then. When you put your phone in the power saving mode, like your phone is only 20% charge or 15% charge, and your phone is in the power saving mode, so in that case, what will Android do? All of the apps that are running in the background, it will be limiting it. Either it will be terminating it, that you will not be able to, run in the background. If in case the user opens you, we will give you a restart. We will give you a reboot. But if in case the user does not interact with you, we will be terminating you. So like that, we will be having the activity in the fourth stage, that is destroyed. So for the sake of freeing up the memory, for the sake of freeing up the resources, Android operating system can terminate the process, can kill the process. That is when we go into the fourth stage. This is the life cycle. First, the activity will be in the foreground when the user will be interacting with it. Then, when the activity is shown on the screen but the user is not interacting with it, then the activity is running, but it is running in the background. It is not shown to the user. It may or may not be terminated by the Android OS. And the fourth, that is destroyed, where the Android operating system can terminate or kill any of the activity for the sake of survival when the battery is low or on the basis of any of the specific trigger. So this is activity. Each unique screen that you have in any of the Android app, this is an activity. We are discussing Android application components. So this is an activity. Service is something that will be running in the background without any of the user interaction. Just like we get the messages on the WhatsApp app, you are not using your phone. Even if in case your phone is locked, you are getting the messages. That is when we run it as a service. So that's a service. Along with that, another thing that we have here is the intents. For you to be able to understand intents, you need to first understand the real life meaning of the term intent. The real life meaning of the term intent is intention or purpose. So from that, the term intent has been derived. As I mentioned that in any of the Android app, you will be having components. Like for example, you have got 4 activities. So with the help of intents, we can get the application to interact with the other components. That is intents. Now the apps can interact within themselves, like Gmail app can interact with Google Drive, WhatsApp can interact with Facebook. Either that kind of interaction will happen, inter-app communication, or as we call it, inter-process communication. Because as I mentioned it in the previous discussions, that in Android, each of the app that you will be running, it will be running as a process, because Android is inspired from Linux. For that reason, in Linux, any of the task that you will be running, any of the software, any of the tool that you will be running, it will be running as a process. Similarly, in Android as well, when you will be running any of the Android app, that will also be running as a process. So when you have to perform inter-process communication, that is IPC, with the help of intents, that can be done. All of the various application components that you have, they will be communicating with the help of intents. For example, you are on your email client, like let's say you open Gmail. In Gmail, when you are visiting, you got a mail from the activist and they mentioned that the new batch for network VAPT is starting day after tomorrow. Click on this button to register for a free demo. So when you click on that button, you get to see a app provider, that how do you want to open this link? Do you want to open it with the you know browser, with the Chrome, with Firefox, with Opera? How do you want to open it? So that is being done with the help of intent. Inter-process communication happens with the help of intents. There are two types of intents that we have. First one is the implicit and the another one is explicit. Implicit means when in any of the intent there is no app component mentioned. Whereas in explicit, which app component is to be interacted with, or which of the app component is to be communicated with, that will be mentioned in the manifest file. I'll take you to the manifest file, and when we have a look at the intents, here you can see we have got the intent filter. So what happens in intent filter is, intents filter will be indicating what are the actions that the receiver is meant to listen for. Now I can understand that it can get a bit technical. I'll make it easy for you. Receiver means whenever any of the command is sent, command as in when any of the task is sent, any of the communication is sent, that when this happens, perform this. When any of the email link is being clicked, ask the user to open this in the browser. That what action do we have to take, that is mentioned in the intent filter. Like as you can see with this activity, like here we have got this activity. The name of this activity is com.twitter.android.widget settings activity, and for this particular activity we have got an intent filter. What action is to be performed for this activity? Android app widget action app widget configure, like this. So what intent filter will do, depending upon which of the receiver do we have here, what action is to be performed. That is what we do in the intents. So here, this is the particular app component that is defined. And because this app component here is defined, for that reason, we call it explicit intent. Explicit intent is when the app component is defined. In implicit intent, there will be no app component that will be defined. It will only be having an action. So that is what we have in the implicit intent. No app component. This is an example of an app component, that when you receive this particular intent, when you receive this particular event, this is the particular action that you have to perform, like here. Similarly, you will be having other intent filters as well. Here, as you can see, this is another intent filter. This is the particular action that has to be performed for this particular activity, based on what which of the particular receiver do we have to work for, what action do we have to perform. Here it is. So these are intents, activities, intents, services, and next one that we have here is the broadcast receiver. This itself, the name itself is self-explanatory: broadcast receivers. For you to be able to understand broadcast receivers, you first should be understanding the meaning of the term broadcast. To give you a real life example of a broadcast, you must have seen that whenever you are watching IPL, when you're watching IPL, in the sponsors, you get to see broadcasting partner Hotstar, broadcasting partner Sony Live. Broadcast means when you have to propagate, when you have to populate to masses on a large scale, to everyone. That is when we have broadcast. For example, radios. When you are in the car, when you are using your phone, you turn on the radio, you go to a specific channel on a given frequency like 91.9, 93.2, 91.7, 92.7, 104.8, like that. So these are the various frequencies. So anyone who gets connected to this frequency, they will become the receiver. They will be able to receive the broadcast. So from the radio station, the broadcast would be sent out. They will tell you that we will be playing this song on this frequency at this time. So they are the broadcast senders. We, as a consumer, we are the broadcast receivers. On that given time, we will be tuning our radio to that frequency, and then we will be able to listen. This is what a broadcast receiver does. All of the various events that are happening in the Android system, events like you are receiving a SMS, events like you are receiving a phone. You must have noticed this, that when on any of the modern day Android application, you request for an OTP, like you enter the phone number and it says auto detecting OTP. You get an SMS, and automatically the OTP that you have in that SMS, it will be autofilled. How does that happen? How does the app get to know that we have received the SMS? How does the app get to know that we have received the call? For example, there are some of the apps that will be asking you to enter the phone number, and they will tell you that now a bot will be making a phone call to you. There is no need to answer it unless you want to talk to a bot. So they will give the phone number, you will give the phone number, they will give you a call, and with one ring, the phone will automatically disconnect and your login will be successful, or your registration process will be successful. So how will the Android app get to know that we have received a phone call, that we have received a SMS? That will be done with the help of broadcast receivers. So what broadcast receivers do, they will be listening for system-wide events. Events like receiving the SMS, receiving the phone call. These are the system-wide events. There are other events as well. I'm taking example of these because you have seen them happening in your real life. So you will be able to relate to it. Now, why are broadcast receivers important? Because the actions that you have in the intents. I showed you these actions. These actions that you have here, these actions will be taken on the basis of the events that happen system wide. System wide as in the Android phone. Like it has told that as soon as you receive any of the SMS, call this activity, perform this intent. So on the basis of that particular trigger, on the basis of that event, that particular intent action that will be followed. So for that reason, we have got broadcast receivers, which means that when any of the event is happening, like as soon as you receive the SMS, read the SMS and autofill the OTP. So that complete process is possible because of the broadcast receivers. Now we have got two types of broadcast receivers. First one is static broadcast receiver, and the another one is dynamic broadcast receivers. Static broadcast receivers, these are the broadcast receivers that can work even when the app is closed. When the app is not active, when the app is not minimized, when the app is closed, static broadcast receivers can work even then as well. And unlike static, we have got dynamic. Dynamic broadcast receivers will be working only when the app is active or minimized. Minimized means that you are using the app previously. Now you are out of that app. You have not terminated the app. You have not closed the app. You are just not actively using it. Like you are using WhatsApp, you had a mail, so you simply switch through the app, you go to Gmail and you read the mail. In this complete process, the WhatsApp has not terminated. The WhatsApp is not killed. It is running in the background. It's just that it has been minimized. In dynamic broadcast receivers, you will only be able to activate them, you will only be able to use dynamic broadcast receivers when the app is active or when the app is minimized. Starting from Android Pie, that is 9.0 and above, by default the broadcast receivers that you will be having, they will be dynamic. Before 9.0, you had the option to choose between static and dynamic. Even today you have the choose, but it's just that before 9.0, the broadcast receiver that we had by default was static. Starting from Android 9.0, 9.0, 10.0, 11.0, 12.0, 13.0, all of the Android versions that we have, by default, all of the broadcast receivers are dynamic, which means that these broadcast receivers can only be used when the app is active or when the app is minimized. The app is running, it's just that it is not running in the foreground. In the background, it is running, it is minimized. So that is dynamic broadcast receivers. And along with that, you have content providers. This is another important application component that we have in Android. Now you can consider a content to be here the data, and providers means those resources that will be fetching or retrieving the data. So content providers are simply those components that will be retrieving the data. Retrieving from where will they be retrieving? They can retrieve the data from the file storage. Like if you have any of the file stored in your internal storage or in your external storage, from there they can retrieve the data. Or if in case it is present in the local database. In Android, the local database is managed by SQLite, usually by SQLite 3. This is a lightweight version of SQL. As the name suggests, SQLite, this is the lightweight version of SQL. It is a RDBMS, that is relational database management system. So this is RDBMS. By default, in any of the Android app that you will be having, it will be using SQLite as the local storage. So using content providers, we can retrieve the data from the local storage. It may be a local file storage, like you will be having the files in the internal storage or in the SD card external storage. So for that also, we can have content providers, and for retrieving the data from the SQLite database from there also. How do you identify the content providers? They will be starting with this URI content, then the package name, and then they will be having the URI like get credentials, like this. So this is how a sample content provider will look like. These are the major app components that you have. I'll be repeating myself. The first one that we have here is the content provider. It is used to retrieve the data, to fetch the data from the internal files, from the databases. You have got content providers. This is how they look like. They will always be starting with content colon slash slash. Then you have got broadcast receivers. Broadcast receivers will be listening for the system wide events. There are two types: static, dynamic. When the app is closed, even when the app is closed, when the app is not active, when the app is not in the running state, even when, if the broadcast receiver is working, then you call it static broadcast receiver. When the app will be when the app will be active, it will be running or it will be minimized, only then, when the broadcast receivers will be working, you call it dynamic broadcast receiver. Starting from Android 9, that is Android Pie and above, by default, all of the broadcast receivers will be dynamic. Then you have got the intents. Intents are used to tell the intention or the purpose. Using intentions, using intents, we will be able to request action from other app components. As I mentioned, all of the various app components that you have, communication between them will be happening with the help of intents. Two type of intents, implicit and explicit. Which app component is to be communicated with? When that is not mentioned, you call it implicit intent. When the app component is specified that on this particular trigger we have to request action from this app component, like any activity is mentioned, any permission is mentioned, anything is mentioned, a certain app component is mentioned, then you call it explicit. Then we have got intent filters, which will be indicating the actions the receiver is meant to listen for, which means that on the basis of that particular intent, on the basis of that particular receiver, which of the action is to be performed. So that will be done with the help of intent filter. Then we have got activities. Depending upon how many screens that you have, each of the screen will be a unique activity. Four stages of activity: foreground, when the activity is being ran, when the user is interacting with it, and in the activity stack, it is on the top. I give you an example of this. When any of the activity will be on the top, that it will be called as foreground activity. Then you are having the second stage, that is visible, when the user is able to see the activity but the user is not interacting with it. Like I gave the example of a WhatsApp chat. You are on your bed, your friends are along with you, you are sitting, you are just conversing, hanging out, you are chatting with someone, you write the message, the other person is typing, but by the time they are typing, you are having a conversation with your other friends. So in that case, you have lost the focus on the chat, you have lost the focus on the activity on that particular WhatsApp chat, and but still on the Android device, on the screen, that activity is visible to you. So that is visible. The third one that we have, that is stopped or hidden. This is when the state of the activity, like you have entered some of the details in the registration form, but you have not submitted it, but you are out of the activity, you have switched to some other activity, when the state of the activity is retained but it is not shown to the user, that is when you call it stopped or hidden. And these types of activities that are in this stage, stop or hidden stage, in this case, in this place, you will be, or an Android operating system, it can terminate or kill that process if in case the memory is required. And the fourth stage that we have is destroyed. In this stage, the Android operating system, they will be terminating or killing the process for the sake of survival, for the sake of saving the memory, or if in case any other application, any other process requests for more memory, requests for more resources, they can free up the memory from here and they can allocate the memory to that process. The last one that we have here is the service. Service are basically the background processes that will keep on running. Like if you are having a music player, the services will keep on running in the background even if in case you turn off the screen, even if in case you come out of the app. When the app is closed, that particular service will get terminated. Similarly, on Gmail, on WhatsApp, continuously they will be checking to the server if in case they have received any of the new message or email. So that you do with the help of service. Along with that, these are the major app components. Along with that, in the manifest file, you can also come across various other keywords. Like you can get to see uh, minimum SDK or max SDK, targeted SDK. Like if I search for it here, so in this one we don't have it. You can have other keywords as well, like min SDK. SDK here is short for Software Development Kit. Any of the Android app that is being developed, that Android app is made for a specific version of Android. We understand Android by their names, like this is Android Marshmallow, this is Oreo, this is Pie, this is ice cream sandwich. For the Android application, for the Android operating system, it is defined by their API levels, like API level 31, API level 26. They keep on getting incremented with the newer versions. So in Min SDK, what the developers want to write is 26. It means that this particular app cannot run on those Android devices where the operating system API level is less than 26. If in case you want to have a look at the chart, here you can see. So API level 29 is associated with Android 10. You can also get yourself a list of no various API levels. Here you can see. Here you can see. So for Android version 4.0, API level is 15. For 6.0, 23. For 8.0, 26. You must have noticed it that for some time, if in case you do not update your app, if you are trying to install an app on any of the older device, it will give you an error, cannot install app on this device, minimum SDK version failed. Minimum SDK version means that here we have got the API level 26. While I am developing the app, I want to ensure that my app should not run on any of the device that is older than Oreo, that is older than Android version 8.0. Now you might be wondering that Rohan, why would we want to do that? There are multiple reasons for that. The first reason that I see is the dependency. As in the later versions of the Android, the libraries that we have, the functions that we have, the capabilities and the compatibilities that we have, that is much higher. Also, the security that we have, that is also good as compared to the previous versions. So we would want that the devices on which our application is running, first the app and the components that we have used in our app, the libraries that we have used in our Android app, it should be compatible, it should go with the Android version. So for that reason, we would not want to run our Android app in any of the older version than that. Like there is any of the library that is available only from Android 8. In the previous versions of the Android, it is not available or it is not supported. So in that case, we will be setting the value of min SDK version to 26. When Android will be installing that app or Android will be running that app, it will be checking that this app is meant to run on no older than API level 26. We are currently using this particular app on API 25. This means that this app is not meant for this device. That is why we cannot run it. So that is min SDK. When as a developer, as an organization, you want to ensure that your app is installed only after a given Android version API level. That is when you use min SDK. You do not write the Android version 9 or 8 here. You give the API level. Like you give 26. Then when you will try to install or you will try to execute that file, that Android app in any of the Android device, it will first check that the device on which it is being installed or it is being executed, is this particular API level for this current device more than or equal to 26? So that is when we have it. The next one that we have is the targeted SDK. Targeted SDK means that this app that we have developed, we have targeted 27. 27 is the API level that we have kept in mind that this app will be running on API level 27, that is Oreo, Oreo 8.1, like that. So when as a developer, as an organization, you have a version in mind that this app will mostly be running on this version of Android on this API level, you mention that in the targeted SDK. And the third one that we have is the max SDK, that this app at max latest it can run on 29, that is API level 29. If in case we go beyond that, if any of the user is using more than that, we will not be able to follow it, we will not be able to run this app. These are optional, not all of the apps will be requiring it. But why have I discussed this with you? So that you can understand that from then on, when you will be testing any of the Android app, what is the minimum SDK version, what is the minimum Android version, Android platform version where you have to test it. For example, the lab setup that you have done, that is in Android 6.0, that is Marshmallow. The app that you are testing, the minimum SDK version is 26, that is Oreo. So in that case, you need to set up a device that is in Oreo and then you will be testing it like that. So for this reason, you need to ensure that the particular app that you are having, you are testing it in the least secure environment possible so that we can check, we can test for the robustness of an application, that if there is no external help, if there is no external security parameter in place, how robust is our own app that it will be able to withstand the attacks. That is what we have to see. So today what we have seen, we have discussed about various Android application components. We started with learning how do you review any of the Android manifest file. What we have discussed are the major Android application components. If in case you are not able to grasp a lot of it, that is not a problem. In the upcoming discussions as well, when we will be requiring to see any of the Android app components, when we will be requiring any of the app components, I will again be revising, I will again be describing and defining that this is what this particular app component is doing. So if in future we will be doing an activity bypass, again I will give you a review that this is what an activity means and this is how we are able to bypass it. This is what an intent filter means and this is how this is the vulnerable code. This is what a service means. This is how we are able to bypass it. This is how it is a misconfiguration. So even if in case you felt that a lot of information you have grasped today, you are not able to process all of them, that is not a problem. In the upcoming discussions as well, I will be explaining the same things to you in different ways. So you will be able to understand them. Even if in case a lot of things were a bouncer to you today, don't worry. It's my responsibility to help you understand each and everything, to get your concepts clear, to get your core strong. All of the methods that are present to get your core ready, I'll be using them and I'll get your fundamentals strong so that when you go as a pen tester, you go as a bug hunter, you go as a Android security researcher, you are able to get the best out of it. You are able to get the most out of it. So today we have discussed various Android application components. In the next discussion, I'll be continuing it on the same note, wherein tomorrow we will be discussing about what are the various things that you need to check in the Android manifest. Today we have seen about Android app components. Tomorrow we will be reviewing this manifest file from the perspective of a pen tester, from the perspective of a security researcher. This is what we will be doing tomorrow. Now, if you have any questions or queries, we can discuss them.
Rohan, please share the text file.
Sure, I'll do that. I'll share that in the group.
Yeah, thank you, Rohan.